The topic for today is preferential discharge of ions during electrolysis. The product formed at the electrodes depend on the nature of the electrolyte. You are welcome. Preferential discharge of ions during electrolysis. In the electrolysis of a given electrolyte, the products formed at the electrode depends on the nature of the electrolyte. If the electrolyte is a liquid or in the molten form, example, liquid sodium chloride. Sodium chloride will ionize to give sodium plus chlorine minus. The cation will migrate to the cathode where they are discharged. The anion migrate to the anode where they are discharged. Where the electrolyte is a solution, that is, it has dissolved in water. The products formed at the electrodes will vary because the solvent, that is water, will ionize and migrate to the electrode where they compete for discharge. The products formed will now depend on which ion will preferentially be discharged. The ion that is preferentially discharged is determined by three factors. A. The position of the ion in the electrochemical series. B. Concentration of ion in the solution. And C. Nature of the electrode. A. Position of the ion in the electrochemical series. An ion, that is a cation, which is less electropositive or lower in the series, will preferentially be discharged. An anion which is less electronegative, that is higher in the series, will be discharged in preference to the ion that is lower in the series. The electrochemical series can be represented here. At the top is potassium, followed by sodium, followed by magnesium, followed by aluminium, followed by zinc, followed by iron, followed by tin, followed by lead, followed by hydrogen ion, followed by copper, followed by mercury, followed by silver, followed by gold, in the increasing preference for discharge. Then the anions follows the same way. Hydroxide ion, iodine ion, bromine ion, chloride ion, triazonitrate ion, tetraoxosulfate ion, and fluoride ion, in the increasing preference for discharge. B. Concentration. Increasing the concentration of ion in solution will favor the discharge of such ion if their position in the electrochemical series is very close. It means that their position in electrochemical series take precedence before concentration. C. Nature of the electrodes. Some electrodes have strong affinity for certain ions and may influence the discharge of such ion. Example, in the electrolysis of aqueous sodium chloride using platinum electrode, hydrogen ion is discharged. If mercury cathode is used, the mercury will associate with sodium ion to form sodium amalgam. Sodium ion plus mercury will give sodium amalgam. Electrolysis of dilute tetraoxosulfate 6 acid. The electrolysis of tetraoxosulfate 6 acid is also called the electrolysis of water. This can be prepared by adding little acid to water. 3 ions are released in the solution, that is, hydrogen ion from the tetraoxosulfate 6 acid and hydrogen ion from ionization of water, then tetraoxosulfate 6 ion and also the hydroxide ion. The hydrogen ion migrates to the cathode where they are discharged by acquiring 1 electron each to form neutral hydrogen. They now combine to form the atomic molecule. Hydrogen ion gain electron to form hydrogen. Hydrogen combine with hydrogen to form hydrogen molecule, which is a gas. Anode. The tetraoxo 6 ion and hydroxide ion migrate to the anode, where hydroxide ion is preferentially discharged. Each hydroxide ion loses its electron to the anode to become a neutral OH group. Hydroxide ion to give OH plus electron. OH plus OH to give water plus oxygen. Oxygen plus oxygen gives oxygen molecule, which is a gas. At the cathode, 4 hydrogen ion will gain 4 electrons to give neutral hydrogen 2 molecules. At the anode, 4 hydroxide ions will lose 4 electrons to give 2 molecules of water and 1 molecule of oxygen. The overall reaction, 4 hydrogen, 4 water molecule to give 4 hydrogen ion plus 4 hydroxide ion. As can be represented below, we have 2 volumes of hydrogen at the cathode, 1 volume of oxygen at the anode, and the ratio of hydrogen to oxygen is 2:1. The discharge of hydroxide ion disturbs the ionic equilibrium of water. To restore the equilibrium, more water molecules ionize, as can be represented by this equation. The total amount of acid in the solution is unchanged, but its concentration increases due to the removal of water. Exercise 1. A metal M displaces zinc from zinc chloride solution. This shows that A. Electrons flow from zinc to M. B. M is more electropositive than zinc. C. M is more electronegative than zinc. D. Zinc is more electropositive than M. The correct answer is B, because M is more electropositive than zinc, as the more electropositive metals displace the less electropositive metal. Exercise 2. Which of the following is not a factor affecting the preferential discharge of ion during electrolysis? A. Nature of the electrode. B. Concentration of the ions in the electrolyte. C. Position of the ions in the electrochemical series. And D. Temperature of the solution. The correct answer is D, because temperature of the solution has no effect in the preferential discharge of ion at the electrodes in electrolysis. Exercise 3. The product of electrolysis of aqueous sodium chloride using mercury cathode is A. Sodium amalgam. B. Hydrogen. C. Mercury and sodium. And D. Sodium and mercury. The correct answer is A. Sodium amalgam, because mercury has a special attraction to sodium.